incredibly warm and friendly welcome just to get started. So really my goal with this talk today is to, I guess, get you interested or excited in the possibilities of, a spreadsheet or Excel as a programming canvas, and the way that's been enhanced by adding functional programming. So to start off, here's a short kind of demo just to set the scene. And this is something that you can build in Excel today. So we're going to take today's date, and then we're going to write this function, and it's going to create a calendar that's going to spill into the grid. And then we can take that a step further and pass in this sort of itinerary that I've made, and it's going to overlay the symbols in the grid. And so we get this nice little visualization where you can see sort of flying out, doing some Lambda-based stuff, then coming back. And so the function, month calendar, this doesn't exist in Excel today. It's not sort of something provided, but it's what you can build now because Lambda's been added. And so I'll be sort of talking a bit later, going through the details of what you see here. But I'll just sort of step back and introduce myself and the team I'm in. So I'm in Calc Intelligence, which is a team in MSR Cambridge. And we've been collaborating with the Excel team for a number of years. And we're a multidisciplinary team, including machine learning researchers, programming languages, HCI, research engineers. We've done numerous things. One of them, so we built the calculation engine for Web Excel that sort of got spun out from a hackathon that we did back in 2017. Recently, we built AI-powered formula suggestion for Web Excel. So this, you just type equals and you get this suggestion for a table aggregation. But the project that we've been working on with Excel, most relevant for today, is Project Yellow, and that's really reimagining Excel as a programming language. So Excel has always been a programming language because you've got formulas and they're code of sorts. But Project Yellow was really about bringing in the concepts from general purpose programming languages, such as compound data types, function abstraction, and using that to kind of supercharge spreadsheets. And the ideas of this really started almost 20 years ago. So Simon, who's here at the conference this week, he sort of spoke to the Excel team and really pitched this vision. And then over the last kind of 6 years, many of these ideas have now been landing in the product. So an example of some of the new concepts, so we've got what are called dynamic arrays. So when you have a formula and it computes an array, that array is now going to spill into the grid where each array element gets a cell. And then you can reference that array using this hash operator, and so that's going to grab the whole array, and then you can use that in downstream calculations to do filtering. And the beauty of spreadsheets and Excel is that it kind of all recalculates. So if I was to go and change the original sentence, even though the array is going to shrink as it spills out, the downstream calculations still work. And that resizing property, that's dynamic, that's where the name dynamic arrays comes from. Another part of this yellow vision was around new data types and going beyond just strings and numbers in cells. So one of those are images. So now you can write an image function, and it's going to go to a URL and drop that into the grid. And this is not special cased sort of at top level if image appears in a cell. This is really images as values that can flow through calculations. But the most important one, at least in my opinion, is, of course, Lambda. And so at the end of 2020, Excel announced that they were going to be adding Lambda into Excel. So you can turn formulas into custom functions. But just to be clear, so it's custom functions, but it's actually really functions as first-class values. So you can write formulas like this now, where it can take, define a twice function, takes a function and applies it twice. I can save that into a parameter, and then I can define this +4 function, that adds 1 twice and then does that twice again. And then we can map that over numbers 1 to 5, and then that spills out like here in this dynamic array. And so, this is kind of a simple example, but it really demonstrates that higher order functional programming is sort of, very possible in Excel now. And then, of course, we have to have an obligatory XKCD. So, Excel has been referenced in a comic before, but this was the first time that a Microsoft research project got picked up. And so this was, really cool. But one of the things that it sort of hints at, and this is, often people say this, is, maybe spreadsheets are not the most maintainable or reusable software artifacts around. And we were hoping that, Lambda should improve this. With the release, we did a research study that looked at forum comments on things like Hacker News or YouTube to see how people reacted to the introduction of Lambda. And there was lots of positive stuff, but then there was also some kind of negative stuff where people thought, it's actually going to make spreadsheets worse because now you've got this sort of the ultimate tool and people are going to shoot themselves in the foot. And then also, people identified that while you have this capability that is incredibly powerful, some of the tooling doesn't match. The formula editing experience is far away from, let's say, VS Code. But we saw this as a positive challenge. So when Lambda went to general availability, we were working on a project in collaboration with them called AFE, or the Advanced Formula Environment, which was an Excel add-in that was designed to really help people push the boundaries of what they could achieve with Lambda. So both in authoring complex formulas and lambdas and then sharing them. And so that was the thing that you saw in the opening image, that sort of code editor. Talk about AFE in a bit more detail. So its sort of most modest capability is just it helps you write functions using Lambda in a easier interface. So you can define this function, give it a name, group by. It's got a nice sort of text box for defining the arguments, and you can write them in pills, and then you can define the body of the function. And so this is a simple group by that lets you take this table and then group by product in this case, and then do an aggregation to compute the sales by product. So that's sort of a modest increment on what you could do before. But we sort of really wanted to push the boundary a bit further, and so we introduced the concept of sort of modules, which is really this textual format where you can write collections of formulas or lambdas to build sort of kind of complex things. And so this was the calendar example that you saw earlier that I wrote. This was the implementation. So these are all just formulas, but you have things like comments and syntax highlighting, layout, and so on. We call these modules, but it's sort of a very lightweight term. It's really just to help people organize these things. But you do get some affordances. So if you were to use this in another formula, you get autocomplete. So it kind of knows about the members in the module. And we're not quite at the point where we have true encapsulation in these modules, but that's sort of something we're interested in exploring further. But one of the nice things about this textual notation is that it's very easy to share now. So you can put it onto GitHub in form of gists. You can then give people those URLs, and now you can start sort of sharing and adding those separately from the workbook or the spreadsheet. So to sort of combine all of these things, what you can do now here, so this is AFE, you can just go to this import feature, put in the URL to your gist, give the name of the module that you want, and then go straight to a cell, and now I can just drop in a calendar very easily. It's just a simple function. And so now users, they have a very, they can significantly improve what they can do in a spreadsheet very easily just using formulas. So previously people were doing horrible things with VBA or other things like that, but now it's just pure functional programming. So I think this is very cool, being able to write all of these complex files of lambdas, but not everyone who uses spreadsheets is an advanced programmer, and so this isn't for everyone. Many people actually write spreadsheets like this. So they have this calculation here. They want to compute an amount based on the price of some fruit and then a quantity. And what they do is they sort of break this down into steps. So you can read this. Each row is a different case, and then the columns are the intermediate parts of the calculation. And I've got the formulas at the bottom. So he starts off with the text after, just to do some string manipulation, and then we eventually extract the number, and then we convert that convert that to a number, and then we multiply it to get the amount. So this is very approachable for many spreadsheet users, but it would be great if they could take this thing that they've built and then package that up into something reusable. So what you can do is you can take this calculation that you've built, you select the range that it's defined over, and then if you open AFE and go to this feature called Import from Grid, what it's going to do is it's going to detect, oh, there are some parameters here and there's a result. So it detects that this amount column here, G3, is an output because nothing else depends on it. And then it also detects that you've got some parameters because these are just values rather than formulas. And so you've got this interface now. And this can then all be rolled up into this nice function where each intermediate step becomes just a binding and a let statement. And one thing that I think is really nice is that we use the headings in the table to suggest the parameter names. So now users kind of have the best of both, where they can define their function in the grid using this very visual feed notation, see all the intermediate parts, and then they can just scoop it up to reuse. And this was kind of nice because it was sort of closing the loop in a sense around Project Yellow and how it started. So this was a paper back in 2003, and this was one of the papers that really inspired Project Yellow and got it going, because Simon is on this and was one of the people that founded Project Yellow. And then nearly 20 years later, on YouTube, we've got Mr. Excel, who has been using AFE or Excel Labs to take what are these sheet-defined functions and make videos about them and tell it to people. And this was great because it's really showing these research ideas then just kind of landing in the more mainstream. And this was one of the reasons why we took the approach of releasing an add-in and sort of trying to do the sort of early research in sort of the public sphere and then to get feedback on these things. So here you'll see this is called Excel Labs, and I was previously talking about AFE, or the Advanced Formula Environment. That's because this year we sort of expanded the scope of this research collaboration to something called Excel Labs, which is now an umbrella for AFE, the formula editor that we built. But the reason why we expanded this is because of this small thing called ChatGPT that you may have heard of. And if you haven't heard of ChatGPT, I'm amazed, but it's these family of large language models by OpenAI that allow you to do sort of text completion based on these prompts. But the collaboration that we wanted to do with the Excel team was to imagine what it's like to have these capabilities sort of directly embedded in the grid as functions that you can call, and to start to explore what people are going to do with this. So as part of Excel Labs, we added this function, labs.generative.ai, and you give it this piece of text, which sometimes called a prompt, and then it's going to go off to the language model and it's going to generate a completion. This is what you get back. I think it's pretty reasonable, but I sort of feel obliged to add in a disclaimer of always fact check the things that come out of language models. But this is very simple. It's just a short piece of text or a prompt that we throw and we get back. And you could also get this from a search engine. But where I think things start to get interesting is when you combine this powerful building block with the other powerful building block, which is Lambda, to build new functions that do very specific but powerful things. So here's that module format that we had before, and now we can define and combine Lambda and this generative AI function to start to build these new pieces. So for instance, we have this classify function, and what it's going to do is it's going to take some categories, and it's going to take some text, and then it's going to try and classify that text according to the categories. And so we're doing some sort of basic prompt engineering here with this string and piecing it together. And then when you combine that in the grid, you can build some really amazing experiences. So if I go back to my itinerary table and I decide, oh, okay, I want to add sort of a category for each one of these events. Now, I could go through and type this manually, but if it's a big table, that's kind of boring. And it's not something that you can just write with a traditional functional programming because, text has lots of intent and, you can't do. But it's something that a language model is going to be great for. So we can take our generative AI function and then we can pass it the list of categories that we're interested in. And then we can throw those across to the language model, and it's going to go ahead and categorize all of these things based on the name, and so we get back all of these tags. And there's sort of one extra small detail here, is that Excel now in the grid, you can make asynchronous function calls as well. So that's sort of an extra thing that just increases the power. Okay, so just to sort of finish up, I guess I talked about a couple of things. So we added AFE to complement Lambda, which is now in Excel, to really try and push the boundaries of what people can do with formulas and pure functional programming. And it's been kind of amazing having people that do not sort of consider themselves programmers watching YouTube content creators to learn about recursion. And they've never done a programming course in their life, but this was sort of unlocked by the combination of sort of the very mainstream surface of Excel and then pure functional programming. And then with Excel Labs, we're sort of expanding the scope a little and trying to understand what happens when you combine Lambda, this powerful abstraction mechanism, with sort of generative AI and language models and the types of new functions and tools that you can build. So if you're sort of interested in learning more, if you want to actually try out any of these tools that you saw, AFE or the function, you can go to aka.ms Excel Labs. If you're interested in learning more about our team and the stuff that we're doing with Excel, then you can go to aka.ms calcintel. So, thank you.
Thank you very much. So now we have 1 minute for questions.
It's a bit sad that Phil Waller isn't here because I have a question about syntax and not about semantics. So I think this is probably the only programming language in the world where you have a Lisp-like syntax just with the parentheses at different points, right? So you have let as a function and then listing all the things. Have you explored any alternative syntax that might make it more beginner-friendly? Because I feel that if you have like these very nested formulas, they could become a bit overwhelming for people who are non-programmers.
Yeah, thank you. So yeah, I completely agree that the let syntax that is there is not nice and makes it hard to read. I think the reason it's like that is because it sort of is a subset of the syntax already available. However, function application syntax is not great for variable binding. So yeah, I would definitely love to explore that more. And in the module notation that you saw, where you have like name equals and then a definition, I think it would be very natural to extend that to work sort of to replace let, as it were, or be syntactic sugar. So yeah, that would be a great thing to explore.